Today we are going to learn the chapter coordination compound, and let us solve some of the important MCQs on this chapter. Okay, our first question is, which of the following complexes exhibit the paramagnetic behavior, where Gly is for glycine, En is for ethylene diamine, and BPY is for bipyramidal moieties. Okay, now if you see the oxidation, you have to derive the oxidation state of each element. Okay, so paramagnetic behavior is basically shown by those compound which has highest, what we can say, which has highest number of unpaired electron. Okay, so let us start with this. First of all, this first of all, CO, let us see CO. So the configuration, electronic configuration of CO is 1s2, 2s2, 2p6, 3s2, and 3p6, and 3d4. Okay, so here, if basically the oxidation number can be 4. Okay, but if you find the oxidation number of this compound, that is CO, in this compound, you will get the oxidation number as, okay, I'll solve the first one. You can basically solve the same for the other one. For example, if we have to find the oxidation number of CO in this compound, so take CO as X plus 2 into oxidation number of OX is minus 2, plus 2 into what is the oxidation number of OH, it is minus 1. Okay, it is equal to, as it contain minus sign, it will be minus 1. Okay, so solving this, X value is equal to how much? X will get as plus 5. Okay, but here you can see 4 and here it is 5, but generally your oxidation state is what? 5. This is not exhibited by cobalt can exhibit only the oxidation state plus 2, plus 3, and plus 4, not more than that. So this is the invalid compound. Now let us go for Ti. If we see that Ti, so the electric configuration of this compound, that is Ti over here is, okay, so Ti electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and 3d1. Okay, here you can see that the number of unpaired electron over here is 1. So what I can say, that number of unpaired electron is equal to 1. Okay, in the third compound over here, let us first of all find the oxidation state of V. Okay, so oxidation state of V, by same method, if you find it out, oxidation state of V is come out to be plus 3. Okay, and its electronic configuration of V3 plus is equal to 1s2, 2s2, 2p6, 3s2, 3p6, and 3d2. So the oxidation number, so here you can see that it contains 2 unpaired electron. Okay, and the last one, if you see the, if you solve and derive the oxidation state of Fe, the oxidation of state of Fe becomes plus 2. Okay, so what is, you have to take the electronic configuration of Fe plus 2, sorry, 2 plus. Okay, so it will become what? 1s2, 2s2, 2p6, 3s2, 3p6, and 3d4. Okay, so here you can see that the number of unpaired electron is 4. Okay, so here which one has the highest number of unpaired electrons? So it is Fe2 plus. So the correct answer is D. Okay, let's move to the next question. Next question is, in which of the following coordination entities the magnitude of delta naught, that is crystal field splitting in octahedral field, will be maximum? Okay, so atomic number of cobalt is given to us. Now over here, when what we can say, in crystal field splitting, when the ligands are arranged in the order of magnitude crystal field splitting, okay, that is, you have to remember the spectrochemical series, that is the arrangement of the electron or the ligands. Okay, so we have seen the series as, for example, if we have the series I minus, okay, then it is Br, Cl minus, okay, then NO3 minus, okay, continued with F minus, and in the middle it will come H2O, okay, then it will be NH3, then it will be En, then it will be NO2 minus. You should know this all. Okay, then it is Cn minus, and then it is cobalt. Okay, now if you can see hydrogen has the neutral spectral chemical series. Before the hydrogen, these are weak filled ligand, and after the H2O, it is strong filled ligand. Okay, so here NH3, En, NO2, Cn minus, and CO are the strong filled ligand. Okay, so if you see everything, so it has been observed, what is observed that okay, so crystal field splitting in octahedral basically depend upon the nature of ligand. Okay, crystal field splitting in octahedral will basically depend upon the strength or basically nature of ligand. Okay, nature of ligand means what? The stronger the ligand, okay, what we can say, the stronger the ligand, large will be the value of delta naught. Large will be the value of delta naught. Okay, so here which among this is the strong filled ligand? Okay, Cn, C2O4, H2O, NH3. So what is the answer? It is Cn, because we have Cn here is the strong filled ligand. Understood? Now next question. Out of TiF62 minus, okay, out of this following compounds, okay, the colorless species, you have to find the colorless species. How to find the colorless species? The colorless species is basically colored species. Okay, do remember that color species is obtained when it contains unpaired electron. Okay, when the compound contains unpaired electron, okay, unpaired basically d electron, then we can say that it show colored species. Why? Because if the compound has the unpaired d electron, it will undergo d to d transition. Okay, and this d to d transition is responsible. What will happen during the transition? It will absorb some wavelength of light. Okay, and the unobserved light, wavelength of light which is reflected back, resembles some kind of color. Okay, so that is what the color is shown by d to d transition. Now in case of, let us see this one by one, like we have F62 minus. So let us take this one by one. So F62 minus, so the ion will become, if you obtain the oxidation state, it will become Ti4 plus. It will give you the configuration as 3d0. Okay, here no electron, unpaired electron is available, so this is colorless. Okay, now the second compound over here, let us take, it is COF6. Okay, COF6 3 minus. Okay, it has the cobalt as CO3 plus. Okay, so the configuration become 3d6. Here again it is colored because it has the unpaired electron in it. Okay, next is let's take CuCl2. So CuCl2, okay, here the ion is Cu plus. Okay, and the electronic configuration become 3d10, so it is coloredless. Okay, so this is coloredless. Okay, and in case of NiCl4 2 minus, okay, that is the nickel ion, Ni2 plus, the electronic configuration become 3 8, that is it has the unpaired electron, so this is the colored one. Okay, so here you can see which are the two colored one, that is COF6 3 minus and the NiCl4 minus, and which are the uncolored one. Okay, it is TiF62 minus, and the other one is it is CuCl2. So the correct answer will be B. Clear? Okay, now let's see the next question. Which among the following do not show optical isomerism? Now optical isomerism, what do you understand by the optical isomerism? Basically optical isomerism is the process of rotation of a plane of polarized either to the left or to the right, which you have seen. What is polarization? That is which has only one direction, okay, which we have already learned. Now optical isomers are basically those isomers which has non superimposable image. For example, if I take a glass, okay, if this is my glass, so it has the same, it doesn't have it has doesn't have the same superimposable, like your, sorry, let us take your hand, okay, let us take your hand. If you can see your hand is this, so your image will be like this, okay. So this is not superimposable image, okay. So this non superimposable image, if you see CONH3Cl3, this is not going to give you non superimposable image, okay, that is mirror image. Nor in case of this compound, and nor in case of this compound, it will be shown in this compound. How? If you see the if you see basically the arrangement, it will it in the form En, okay. So this 2 3 4 and here the 2, okay. So this is En, this is En. Now this structure in the form of mirror will be shown as, again this is cobalt, okay. So this is En, this is En, and this is En. So it will show the mirror image. So the correct answer is COEN thrice by the 3 plus, okay. Okay, so this is the correct answer. Okay, clear? Sorry, I think so I've got something wrong. Yes, yes, sorry. The question is which do not show. Basically, this will show, okay. Next is COEN twice and CM. So in case of twice, EL will come over here and CL will come over here. So this will also show the optical images, okay. And COEN Cl2 and NH3 twice, okay. Among this will also show the optical images, okay. But in the case of A, it is not going to show the optical images, okay, in case of A, because in case of A, if you see the diagram, it will become CO NH3, this will be NH3, okay. Again this will be NH3, this will be Cl, this will be Cl, and this will be Cl. So in mirror it will not come in this form, okay. So the correct answer is A. Clear? Okay, now let's move to the next question. Which of the following complex ion is expected to observe visible light? Now here if you see the ion, okay, first of all, what is the, if you derive the oxidation state, Ti will become as 4 plus, Ti in the ionic form will be 4 plus. In case of chromium it will be Cr3 plus, okay. In case of this compound it will be Zn2 plus. In case of this it will be Sc3 plus, okay. So this will contain 3d0. If the electronic, if you write the electronic configuration, this will become 3d3, this will become 3d10, okay, and this will become 3d0, okay. Now your transition metal ion containing completely filled d orbital and empty filled d orbital are colorless, okay. Those which have completely filled orbital, here in case of completely filled orbital and here in case of empty orbital, so they do not show colored complex, okay. So the colored or visible of which a compound have observe visible light is the chromium compound. Clear? Okay, now let's move to the next question. Which among the following complex ion is not expected to observe the visible light? So yeah, here you have to tell which is not expected to observe, okay. So basically here if you see, it contains various compound, but over here a transition metal complex observe visible light only if it has unpaired of electron, as we have discussed in the earlier question, okay. So here you can see nickel and nickel as two side, okay, and chromium and ferrous over here, so you have two nickel over here. Okay, so among this two nickel, if you see nickel, what it do in case of nickel, as we have two nickel, we cannot find it out basically which in with the electronic configuration. So you have to in oxidation, if you derive the oxidation state, nickel will become Nu2 plus. So in ground state, you have seen that it have the electronic configuration of 3d8, okay, which is resemblant by, so this is 3d8, okay, 1 2 3 4 5 6 7 and 8, okay. So now over here what you can see, one has cyanide as the, and the second one is H2O. So according to the spectrochemical series which we have learned, the strong filled ligand will cause force pairing. So if this force pairing take place, okay, so if force pairing is happening over here, so what is going to form, this will form the all paired electron, right? So there is one empty orbital, so it will form force pairing, and those which do not have any of the unpaired electron do not basically observe the visible light. So the correct answer is NiCN4 will not show the will not basically observe the visible light. Clear? Okay, let's move to the next question. Crystal field stabilizing energy for high spin d or d octahedral complex is, okay, so you have to tell which one it is. Okay, in case of crystal field splitting for high spin in octahedral, now the octahedral complex is given. So we have seen in crystal field splitting that basically whenever the ligand is going to approach the central metal ion, due to repulsion, what is going to happen, they are split into high energy and low energy. Okay, so here you can see they are split into two form, that is, okay, so here you can have dx square minus y square and dz square, okay, and here you will have dxy, dyz, okay, and dzx, okay. So this have low spin, and this two have high spin. So high spin will have the energy of 0.6, whereas low spin will have the energy of minus 0.4, okay. So the correct answer is minus 0.6 delta naught. Clear? Okay, now let's go for the next question. Next question is the existence of two different colored complexes with the composition of CONH34Cl2 is due to, okay, two different colored complexes is basically shown by the ionization isomer. Okay, it is basically shown by the ionization isomer. So the correct answer is ionization isomerism. Okay, now next question is which of the following complexes is not expected to exhibit isomerism? Okay, so here which of the following complex will not exhibit isomerism? So if you see the electronic configuration over here, everyone will exhibit one or the other form of isomerism. This is going to exhibit, this two is going to this two is going to exhibit, this is going to exhibit, but it is not exhibited by NiNH3 twice Cl2. Okay, so the correct answer is NiNH3 twice Cl2. The next question, which of the following complex ion which which is diamagnetic in nature? Okay, so how to basically see which of the following complexes are diamagnetic in nature? Again here Ni and N2. So here it is shown which is diamagnetic in nature. The answer is very clear. You have to just see the ligands which are attached to the central metal ion. So in case of this is the weak, this is also weak ligand, and this is also weak ligand, but there is one strong ligand, that is cyanide. Okay, and wherever there is strong ligand, okay, so their force pairing take place, and the force pairing causes the metal to form a diamagnetic metal. Okay, so this is diamagnetic in nature. Clear? Okay, now next question is the complex is CONH36. Okay, the complex is given below. Here you can see in case of CONH36, here it is CrCN6, then again it is given CrNH3, NH thrice 6 CO CN6. So here what you can see is, here it is cobalt chromium. Okay, this cobalt has the ligand NH3, chromium has the ligand cyanide, but here it is reverse. Chromium has the ligand NH3, okay, and cobalt has the ligand CN. Okay, so this type of isomerism is basically known as coordination isomerism. Okay, so what is basically, when it comes to linkage isomerism, if any compound has the for example CrCN, if you are taking, okay, so if it is the ligands, it joined by C triple bond N, okay, or the second isomer will be joined by N triple bond C. So the which basically ion is attached to the central metal ion, if it is attached to by the carbon, or it is attached by the nitrogen. So this is linkage isomerism. Ionization means what? They differ in same compound, but they have different ionizing ions. Okay, they ionize different ions, so that is ionization isomer. And also, you know, geometrical isomer showing cis and trans. But in case of this is coordination isomer, that is change in the ligand. Okay, that is exchange of ligand over here. So this is nothing but the coordination isomerism. Now next question, the complex PTPY NH3BrCl will have how many geometrical isomerism? Okay, so you have to tell how many geometrical isomerism will it exhibit. Okay, so let us find out. Let us, Pt is the central metal ion. There is 4 ligand, 1 2 3 4, 4 different ligand. So let us 1, this will be pH, this is the NH3, this will be Cr, and this will be Br. So this is one form of isomerism. Okay, let us draw the second form of isomerism, that is Pt, this will be Py, this will be Cl, this will be Br, and this will be NH3. Okay, we have exchanged the places of Br and NH3. So this is one kind of isomerism, this is second. Okay, now the third type of isomerism will be Pt. Again, here it will be Py. Okay, it will be Br, it will be Cl, and it will be NH3. Okay, so here the isomerism is the third type of isomerism. So isomerism showed by this complex is 3. Okay, so it show 3 geometrical isomerism. Clear? Okay, now let's move to the next question. The d electron configuration of Cr2 plus, Mn2 plus, Fe2 plus, and cobalt ion are D4, D5, D6, D7 respectively. Which one of the following will exhibit minimum paramagnetic behavior? That is, minimum paramagnetic behavior means minimum unpaired electron. Okay, those compound having minimum unpaired electron. So let us see. In case of MnH2O6 2 plus, okay, your Mn2 plus have the 3d5 configuration. So your number of unpaired electron will be how much? 5. Okay, in case of ferrous, it is what? In case of ferrous, that is Fe2 plus, it has 3d6 configuration, right? Okay, so here is 2 plus and it is 3d6. Okay, so but number of unpaired electron in this case is what? It is 4. Okay, why? Because if you see the diagram over here, this is in case of this 1 2 3 4 and 5. So see, 1 2 3 4 and 5, this is 6. So number of unpaired electron will be 4. Clear? Okay, now in case of cobalt, that is CO2 plus, okay, so that is 3d7. So number of unpaired electron will be how much? 3d7. In case of this is 3. Okay, same, you have to just add one more electron over here. Okay, now over here chromium has Cr2 plus ion has the configuration of 3d4. Okay, so the number of unpaired electron will be how much? It will be 4. Okay, so here which has the minimum unpaired electron? That is cobalt. This has the minimum unpaired electron, so the answer is this, because it is asked the minimum paramagnetic behavior. Now the next question. Next question is, which of the following carbonyl will have the strongest CO bond? Okay, in this case, the presence of positive ion on the metal carbonyl, what I'm saying, the presence of carbonyl ion on metal carbonyl would resist the flow of metal electron charge to the pi bond. Okay, this would increase the CO bond order, and hence CO, basically C and O bond in the metal carbonyl cation would observe at high frequency compared to the absorption in the neutral metal. Okay, so here what is the answer? It is MnCO plus, because of the positive cation, because of this positive charge. Okay, so this, why? Because the positive charge will basically resist the flow of metal electron charge towards the CO bond, making the CO bond strongest. Clear? Okay, the next question, which of the following complex compound will exhibit highest paramagnetic behavior? Same thing, you have to see the highest number of unpaired electron. Okay, so in case of this, T electronic configuration is 22. Okay, but Ti3 plus, that is ionic form, you have to first of all find the oxidation number, and after finding the oxidation number, minus the number of electron in this, and then find the electronic configuration. So it will become what? 3D140. Okay, in case of chromium, that is Cr3 plus, it will become 3D340. Okay, in case of cobalt, that is CO3 plus, it will become 3D640. Okay, in case of zinc, Zn2 plus, it will become 3D10. Okay, so here which has the highest number of, here it is complete stable, so the unpaired electron is 0. In case of this, the unpaired electron, in case of cobalt, the number of unpaired electron, okay, because of pairing, okay, because of pairing, as NH3 the strong ligand, because of pairing this will have 0 unpaired electron. Again it is NH3 over here, okay, but it has already 3. Okay, so here the number of unpaired electron is 3. Okay, in case of TiNH3, here the number of unpaired electron is 1, because it is 3D1 3D3. Now here the highest number of unpaired electrons is shown by chromium, that is CrNH363 plus. Okay, so the correct answer is B. Okay, now let's see the next question. Which one of the following is an outer orbital complex and exhibit paramagnetic behavior? Okay, you have to tell which one of the following is the outer orbital complex and exhibit the paramagnetic behavior. Now let us see one by one. Over here, this is sp3. If you solve this question, you will get the electronic configuration, or the hybridization as sp3d2. Okay, so this is outer. Okay, it is octahedral and it is paramagnetic. Okay, again solve this, find out the hybridization. After finding out the hybridization, it will become sp3d2 again. So same octahedral, but it is diamagnetic in nature. Do remember, this is diamagnetic in nature. Okay, in case of Cr, this is d2sp3, that is inner. Okay, so this is octahedral paramagnetic. Okay, and case of d2sp3, this is also inner. Okay, but it is octahedral, but it is diamagnetic. Okay, they have asked you which will exhibit the paramagnetic, outer paramagnetic, so the answer is A. Okay, now let's see the next question. Red precipitate is obtained when ethanol solution of dimethylglycomines is added to ammoniacal, that is Ni twice. Which of the following statement is not true? Okay, in case of this, basically red complex have square planar geometry, complex has symmetrical edge bonding, red complex have tetrahedral geometry. Dimethyl glycomine function as bidentate ligand. Okay, what is the question? Red precipitate is obtained when ethanol solution of dimethyl glycoms is added to the ammoniacal. Okay, now which of the following statement is true? That is the red precipitate. So basically the red precipitate is nickel DMG, okay, 2 minus. Okay, this has basically, if you see the isomerism or see the structure, it shows it resembles the square planar structure. Okay, it will show the square planar structure. Okay, and is not tetrahedral, and not tetrahedral. So the answer is what? It is C. Okay, so this statement is not true. Next question. Low spin complex of D6 cation in an octahedral field will have the following energy. Okay, now here if you see the crystal field splitting, okay, which is equal to 0.4x plus 0.6y, okay, into delta naught plus zp. Okay, where x is what? Where x is the number of electron occupying T2g orbital. Okay, where y is the number of electron occupying Eg orbital. Okay, where z is what? Z is the number of unpaired electron. Okay, so for the low spin, okay, for low spin D6 complex, so the electronic configuration become T2g6 Eg node, or you can write it as T2g222 Eg node. Okay, so x over here is what? It is 6, y here is 0, and z is what? It is 3. Okay, so substitute this value in this equation, you will get the answer as minus 12 by 5 delta naught 3p. Clear? Okay, solving this you will get the answer minus 12 by 5 delta naught plus 3p. Clear? Now let's move to the next question. A magnetic movement of 1.73 bm will be shown by which one by one among the following. Okay, here if you see the magnetic movement over here, so the oxidation, first of all let us see. You basically we'll take one example. Okay, so in case of Cu, okay, what you have to find, first of all find the, in case of each of the compound, you have to first of all find the oxidation state. So I am taking the compound Cu. So Cu in the compound this will have the oxidation state of +2. Okay, by solving you will get the answer +2. So the electronic configuration of C2 plus will become 3d9. Okay, that is one unpaired electron. Okay, so what you can say, n is equal to 1. Okay, substitute this in magnetic movement formula, that is magnetic movement is equal to n into n plus 2 pm. Okay, which will become, substitute the value of n, it will become root 3 bm. Okay, and root 3 bm is nothing but it is 1.73 bm. So the correct answer is this. Okay, you have to solve each and every compound in the answer, and you have to get the correct answer. So I have all directly solved the correct answer. Clear? Okay, now next question. An excess of AgNO3 is added to 100 ml of 0.01 molar solution of dichlorotetraquachromium 3 chloride. The number of moles of AgCl precipitate would be. Okay, so here first of all write down the compound. It is chromium. Okay, H2O4 Cl2 and it is Cl, this compound. Okay, so when an excess of AgNO3 is added to it, okay, it is going to form Cr H2O4 Cl2, okay, that is NO3 is going to get attached over here, plus AgCl will be out. Okay, so you have to tell number of AgCl. So number of mole is equal to 0.01 into, so that is concentration into the volume, that is upon 1000. Okay, so which will give you what? It is number of mole is equal to 10 by 3. That is the formula. You have to use the formula of molarity. Molarity is what? It is number of the number of moles upon the volume into 1000, right? So same formula, substitute this in formula and you will get the answer 10 to the power minus 3. Okay, so which can be written as 0.001. Okay, so this was some of the MCQs which we have solved on this chapter. Solve more and more MCQs on this chapter. If you have any doubt, please please feel free to ask me. Okay, thank you class.